Hello and welcome back to a new video here on the Ludwig Fusel channel in D3D12Ez, where we draw nicely flashing triangles like the one we have done here. So that's our triangle, it looks nice, it flashes, it's amazing, but it's missing one crucial thing that we need for 3D rendering or rendering nice things in general. Well, a color is nice, but a color is actually not what we want. We don't want to render colors, right? Colors is not the scope of our rendering things. We want to actually render something visual in here. We want to render a so-called texture. We want to render an image inside of the triangle and not just color. And that's what we want to do in the next few videos. Now, getting images to work is not as straightforward as you would think, because images are actually hard. Images are hard to load. It's not simple. There are many ways of doing it. One way of loading images is by using certain libraries. For example, if you want to load a PNG file, there is libpng. If you want to load a JPEG file, there's a libjpeg. And yeah, like every file format has a dedicated library of loading it. But there are also like libraries that support multiple file systems, like for example STBI or STB image, single header files, nothing's images library. It's like a single header that you can put in your project and it's going to load images. There are also other projects like OpenCV that are just like designated for like image operations, image processing, and are really heavy weighted. Now, if you don't want to have a heavy weighted project, you would go for something like SCB image. If you want to have full control, you implement every library on your own, right? An abstraction layer over the libraries that you want to use. However, that's not any of the things that we're going to do, because this is all going to be limited to a certain thing, and we need to have a bit of dependency management, and I want to have this tutorial series dependency free. I don't want to pull in external libraries here. This is why we're going to use the Windows imaging component, so-called WIC. The Windows imaging component is a set of libraries, so actually one single library for loading images. That's the only purpose of that library, is loading images. And the nice thing is it's based on Microsoft COM, it's based on abstraction, and it has a certain inversion of control implemented in itself. And basically what you can do, if you gotta write your own custom image format, you can actually write an extension for the Windows imaging component, register that with the Windows imaging component, and if any application wants to open a image that's using your compression, then it's automatically gonna call your code to decompress it, and the end application developer does not need to change anything in their code, because, well, you registered that certain file extension or that certain file format with WIC. And you tell WIC, alright, this is a file, it has the following metadata, and then it can be decoded by your library and presented in a uniform way to the application. So that's what we want to do today. In the video, we want to implement Windows imaging component. For that, I'm going to go to support. I'm going to add a new item. And this item is going to be called image loader.h. So we're going to write a image loader. That's the purpose of what we want to do today. So we're going to have a class image loader. Now the class is going to use certain things. So first of all, I want to define a struct in here called image data. So that's the image data that we want to load. And then what we're going to have is we're going to have a bit of private constructor, because I don't want to have that one loaded. That library or that class is not allowed to be constructed. It's not a singleton, it's just a container, right? We could do this without a class and just provide a function. However, I want to have a bit of an abstraction around here, and we might in the future also transition that to something else. But the image loader image data is going to be what we want to load. Now, first of all, we need a bit of a container on where we want to load our image, and we can do this in a vector, right? We can put a vector in here, an SCD vector of char for our image data, and we can call it data. Then we have a bit of a container that self-manages itself for destruction and all of that things. Alright, so we have a bit of data. Now, which properties does an image have? Well, an image has a width and a height, so that's something that we want to do as well. I'm going to do this as UN32T, because that is the format that Windows imaging component uses. So we're going to have a width, we're going to have a height, and additionally to these metadata, we also going to have something called a BPP, and we're going to have something called a channel count, or CC, depends on how you want to call it. BPP is bits per pixel, and CC is the channel count. Now, bits per pixel means how many bits a single pixel has. So, for example, if you're having a 4-channel RGB image, you're gonna have 4 times 8, which means 32 bits per pixel. And according with the next value, which is the channel count, which would be 4, you basically know how many channels are in there and what the values of the channel are. However, these formats are also not sufficient. We also need to have a bit of more information on that. This is basically all the metadata that we need to work with the data array. However, at some point we need to kind of like transition this to a DirectX 12 image, and if we are transitioning this to a DirectX 12 image, we need to have a bit more control over how the data is laid out in here, and for that we need a image format. Now first let me include our windows.h or win-include actually for that project. There we go, win-include is in here, and then what we're gonna have is a GeoID, and this is gonna be called the pixel format. Yeah, pixel format, like that. Do you have a problem with that? Can't open source file. Why can't you open the source file? Do I not have my include path set it up correctly? It's under support. It's support when include. There we go. Now it's correct. Alright, so now we have the GeoID. It is a pixel format. Now Windows imaging component uses GeoIDs for pixel formats. However, we can't really deal with these GeoIDs. These GeoIDs are nothing that is really meaningful for us. What we care about is a DXGI format, and this is the GI pixel format. So we're going to have a GeoID as a pixel format, which is used for Windows imaging component, and we have a DXGI pixel format. So Windows, or we could also prefix this with like WIC, Windows imaging pixel format, and GI pixel format for graphics. And these are like all the properties that a loaded image shall have. Now I'm going to write a static. Yeah, let's make a static bool. Load image from disk, and load image from disk needs a path. So we're gonna include file system. So we're gonna have a const std file system path, which is the image path. And then what we're gonna have is a image data reference data. And it's going to be our output. It's going to be image data, and our boolean is going to indicate if image data was loaded successfully. So let's create a C++ file for that, and let's go in and create an implementation. Alright, so how do we load images via Windows Imaging Component? Now, Windows Imaging Component is based out of COM, so to get our first instance of the Windows Imaging Component, we need to call co-create instance. That's the big ass function that Windows uses to create every COM object except DirectX 12, because they have their own factories. And it is going to return a H result. Now, first of all, we need a pointer where we can store that, and we need to know what we want to load. We want to load a so-called WIC Imaging Factory. This is going to be the WIC Factory. Now, as you can see, it's currently not recognized. Because we have not added the correct include. So I want to go inside of my win include, and what I want to include is wincodec.h. In wincodec.h we're gonna have all these like codec stuff, image codecs, etc. And this is the header that we need. And now this should work. Identifier COM pointer is undefined. Did I not include this within win include? That's okay. So let's include COM pointer.h. And now we are good. All right. So the WIC Imaging Factory. The WIC Imaging Factory is a factory class that allows us to create certain instances of WIC objects that allow us to work with it, similar to the DXGI factory. Now, the first thing that this function takes is a class ID. We just use CLS ID as a prefix, and then just WIC imaging factory. It's a predefined macro. If you hover over that, it is gonna define itself to something, and you can see that there are multiple versions of these. It's a WIC imaging factory too, and you can see that this works with defined GeoID, and you can see that there's a GeoID inside of here in the Windows SDK, and this GeoID is used for the class here to know what we need. Then we have this p unknown outer, so the outer pointer, we don't need that, so we put it to null pointer. Then we have the context, and since we are opening this up on the same system and on the same machine, we need to call this one with CLS context improc server, just as it is. Really, there's no big deal behind that, it's just the way you need to call that. And then we just need our IID PPV args to our WIC factory. And there we go. Now the WIC factory should have been created successfully. I want to quickly check if this failed. Or let's maybe define a macro for that we can automatically return null pointer if a call like that fails. Let's define hashtag define __ image loader CCR, check and return expression. So I make my do while 0, right? This is required if you, or do while false. This is required if you want to do an inline macro with code. So if not expression, then I want to return false. That's what I want to do. And I can put this macro around the call. And I made a mistake. No, I didn't make a mistake. So you can see that's good. It expands to that, and this should automatically check and execute the call. And now we should have a WIC factory. What's the problem? Yeah, because I said not. Of course, it's an H result, so it should be failed. Alright. So let's see if that works. Let's make a breakpoint and let's use the call to load a texture, right? We don't have a texture yet, but I wanna already simulate that. So this is the vertex data, the heaps, upload buffer. Yeah, and there we go. Then we copy. And this is going to be texture down here. This is where I want to have the code. Image loader in here. And let's see how we can load that. So image loader, image data, texture data. And then we're going to say image loader, load image from disk. I'm going to provide a path and the texture data, and the path is going to be ./texture.png, even though we don't have it yet. And this allows us to quickly check that later. Alright, so now this should be called. Let's press F5 and see what we got. Of course, everything needs to recompile because we changed our win include, and that's not a problem. Just wait a few seconds. All right. So you can see that we have reached that certain point, and you can see that the WIC factory has a correct pointer, and if we would go to the output, we would probably see that it loaded Windows codecs.dll, which basically meant that this works, right? If I would make the breakpoint before that, restart that, Windows codec is probably not loaded yet, so you can see DWM API has been loaded, and as soon as I go for the Windows imaging factory, we load CLBCKQ, whatever. And we also use Windows codec DLL now and have it loaded into our system. And this pointer should also come from Windows codec. Yeah, Windows. Yeah, of course. Let me quickly show this to you. Windows codec.dll. So what's coming from there. All right. So that means that worked. And now what we have is we have our factory. And with the factory, we can start doing stuff. So the first thing here is basically the factory. The next thing that we need to do is we need to load the image. That's the next step that we need to do. So how do we load the image? Well, first of all, we create something called a WIC stream. The WIC stream is used for containing kind of like an accessor to the image, because a stream is required to read data in image processing, especially like for libpng. I have experience with that. They always work with streams, right? You have your own IO functions on libpng, which is kind of like a streaming function that's called by libpng to read a certain amount or write a certain amount of data. So it's kind of like used as a stream. And what WIC does, it has an abstraction over that stream so that you can create a stream from a Windows file handle, from a memory location by providing a pointer and a size, or from an actual file path. And that's abstracted with the WIC stream. So what we want to have is we want to have an iWIC stream. Here, that one. And this is going to be called the file, or yeah, let's call it file stream. And this stream needs to be initialized. And yeah, basically needs to be created and then initialized. So the first thing that we want to do, first of all, my check and return. This stream needs to be initialized by asking our factory to create ourselves a stream. So what we can do is we can tell it to create a stream. Needs a pointer to a stream, WIC file stream. And that's it. Now the stream has been created. The next thing that we need to do after the stream has been created, we need to initialize now the stream and set it to a certain kind of like size. Well, what you can see is that the stream has many functions. Initialize stream from memory, initialize stream, initialize from iStream region, from iStream, and from file name. So you have multiple ways of doing it, right? You can use an existing iStream, which is like a general stream interface that you could implement yourself. You can also initialize it from an iStream with a defined region, from a memory pointer, from a file name, and I think there's also a way to initialize it from a Windows file handle, but that's, I think, done a bit differently. But we're going to do it from file name. So we need to provide a file name, which is our image path. And I can just take the C string, which should be, we could explicitly say W string and then C string to be 100% sure it always works. And then we want to have a bit of generic read in here as an access mode, because we only want to read from the file. I might need to do a series on Win API programming in the future, isolated from the DirectX 12 stuff, so that we can go a bit more detail in like these Windows imaging components, HWNDs, etc. to have maybe a bit more information in there. But that's not for today. Alright, so now what we have done is we have initialized ourselves a stream, and now we need to take that stream to create something called a bitmap decoder. And the bitmap decoder is a decoder for a bitmap, and the bitmap is kind of like the image file. So what we want to do next is we want to create ourselves a COM pointer for a iWIC bitmap decoder. Bitmap decoder. Don't know why the IntelliSense on WIC is not working that nice. So this is kind of like now the WIC decoder. That's what we want to have, and what we want to do is we want to create a decoder from a stream. So what we're going to do is we're going to ask our factory now again to create the bitmap, to create decoder from. And you can actually see that we could have already done it from file name, from file handle, but we want to do it from stream. From stream is like the preferred way on how you should do it. You should always do it from stream. This is kind of like the idea on how you do it the correct way. So you provide the WIC file stream. We do not need a vendor and decoder options. Now decoder options are WIC decode, and you can see decode metadata cache on demand or on load. On load would mean that it would now decache all the, or it would now cache all the information that's in the file, or we can say that it shall cache on demand, so only if it gets access to it, and we're gonna use on demand here. That's totally fine. Of course, we need to provide a pointer to that decoder that we want to initialize. So what I want to provide is a WIC decoder. Now again, you could have directly used the function that goes from file name. However, I would recommend doing it that way, so that way you're more flexible with the stream. So stream is kind of like the way to go there, or should be the way to go. Alright, so the next thing that we need to do now that we have a bitmap decoder is we need to get a frame from the bitmap decoder, because a bitmap could have multiple frames, right? If you have a GIF, you have multiple frames in there. So what you need to do is you need to basically say which frame you want to have. So now we had a big bitmap decoder, and now what we want to have is a bitmap frame decoder. WIC Bitmap Frame Decoder. WIC Frame Decoder. So now, first of all, we created ourselves a normal decoder for the whole image, and now we have a frame decoder that we need to create, which only contains the one single frame and the only frame that we're gonna have in our image. So we're gonna take the WIC decoder, and we're gonna call the getFrame function. You can see there are many functions like getFrameCount, getThumbnail, getPreview. What we want to do is we want to get a frame with the index of 0 to our WIC Frame Decoder. This is going to give us the first frame and the only single frame that we have in here. Alright, so now we basically have our frame decoder ready, and the frame decoder holds the information about the image that we want to decode. And now what we need to do is we need to go into the step of actually decoding the image. Now, however, decoding the image, it's not really the thing that we want to do first, because we first need to get the metadata of the image. So image, metadata. That's what we want to get now. So as you can see, the WIC Frame Decoder has many functions like copy pixels, which is later on used to copy the actual pixels. But it also has functions like get pixel format, get size, and informations about these things. So the first thing that we want to do is we want to get the size, because that's very interesting, the width and the height as a uint. So we call this one data. So data is the output. Width, pointer to that, and pointer to data height. Of course, we want to check that one as well, like that. And now we have the width and the height. And the next thing that we want to do is we want to have the pixel format. So WIC Frame Decoder, get pixel format. Now the pixel format is a GeoID. The GeoID is stored in the WIC pixel format in here, and now we also have the GeoID of the pixel format. Now this is a trivial image metadata that we want to have, but now what we need to do is we need to get a bit of more information. So let's call this trivial metadata. Now what we need to do is we need to have the metadata of pixel format, because basically what we get is the pixel format, and the pixel format is going to contain the information about like number of channels, bits per pixel, and all of these informations. However, to query these informations, we need to first do a bit of checks on how we do it. So the first thing that we need to do is we need to get a component info. So this is now again a bit spooky on what we are doing. WIC component info. That's what we want to have. It's basically an information about the component that we want to query. Any WIC component, could be whatever it is, but just some information about any WIC component. WIC component info. Now, how do we get a component info? Well, basically we ask our factory to create a component info for a certain component. Now, the component is a class ID or a UUID or GUID, however you want to call them, which is our data WIC pixel format. This is the GUID where we want to get info about. And then we just provide a pointer to our WIC component info, and then it's going to give us some information about the component. And the WIC component info has many functions like author, class ID, component type, friendly name, signing status, and you could get many information. For example, if you have like custom decoders for certain image types, you could get the author and see who has written that certain extension for WIC. But what we want to do is we don't want to use anything of these. What we want to do is we want to call the query interface function to query for a other interface that's implemented by that, because the component info is just a kind of like general base class, and depending on what component is implemented by that GeoID, it has certain subclasses, and the subclass that we are looking for is the WIC pixel format info. That's what we want to looking for, WIC pixel format. That's what we are looking for. That's the component info that we are looking for. We can put this into query interface, provide a bit of checking around that, and then, if that succeeds, we should have information about the pixel format that we specified or was specified by the GUID. Now, this should always work. We should not really need to check that because we retrieved it by get a pixel format, so it should be guaranteed that it works. But again, with like this COM stuff, you should always check the H result to make sure that you're not doing something that's gonna blow up at some point at certain configurations, because you might not know how somebody has patched their computer so that WIC is completely destroyed. Could happen, right? Because it's like COM and registered, and if you are doing bad stuff, you could probably manage to break WIC on your system by providing custom extensions and stuff, by destroying Win codec. But then if you're destroying Win codec, you probably have different problems than like writing games and 3D applications. But yeah. All right, so what we now can do is we can now query these WIC pixel format info. Yeah, let's try. It's just called pixel format, but that's okay. Should be called pixel format info. Yeah, let's maybe call it pixel format info to be completely explicit. Now, what you can see is that this pixel format info has many more interesting features. You can see that it now has something like get bits per pixel, get channel count, get channel mask, color context, and I think that's it. So there are actually now the members that are interesting for us. So get bits per pixel is what we are interested in, which goes to data BPP, and then we have data CC for channel count, and then we're gonna get the channel count here as well. Now again, these calls should be encapsulated in checks, like that. Or what? This is not? Alright, there's a semicolon in here. That's not intended. Alright, so now you can see we have metadata of the pixel format loaded into memory. And that's actually quite nice, because if I now would make a breakpoint, right, and let's see where we are getting. No, I actually wanted to put it in here, right, because that's not going to be hit it. There is the breakpoint that I wanted to set. And we don't hit it. So there's something gone wrong here. Yeah, of course there's something gone wrong, right? Because the image path is not in existence. That's a fair point. First of all, let's go to debugging. Where is my debugging directory? It's the project here. Let me put this to the solution directory. Solution directory. There we go. Now we are debugging at the solution directory, and now we need to make sure that we get a texture. This is our directory. Maybe I do still want to go into subdirectory because it's kind of cluttered. Let's go into subdirectory called app. And in the subdirectory app that we need to create, we want to put the texture. Now I need to quickly find my texture. And here it is, my quite friendly, always used PNG texture for triangles. Let's copy the file name of that, and let's go back into Visual Studio. Let's replace the file name with the proper file name, and let's see what this is gonna do. So now you can see that we hit the breakpoint, which means that everything is correctly set it up. You can see that all the pointers are valid, and if I take a look at my data, you can already see that my width and height is 512, the BPP is 32, and the channel count is 4. We also have a WIC pixel format. The only thing that's missing is like data and the GI pixel format, the DXGI pixel format. If we compare that to what we got here, you can see 512, 512, so yeah, these sizes match. BGRA, which is the pixel format, so 4 component color. You can see that this one matches, right? You have 4 and 4 here, and then we have 32 BPP, which is also matching what's been written here, so 32 BPP. I basically named this file already in the correct way. Of course, you could argue and say it's not correct, but if I would take a look at the texture here, this is like the source here. If I would go to details, you could see the same data here. 512, 512, 32-bit. You can't really see the pixel format itself, but that's okay. Okay, so that's basically the texture loaded. Now what we need to do is, no, not the texture, but the metadata loaded. So now what we need to do is we need to do two more things. So first, what we need to do is the DXGI pixel format. And what we need to do is image loading. Now, I'm actually going to do the image loading first because it's actually simpler than the DXGI pixel format. The DXGI pixel format requires a bit of more new information on what's going on. First of all, image loading. How does image loading work? Well, we have the frame decoder, and basically what we can tell the frame decoder is to copy pixels. And you can see that copy pixels takes a PRC, CB stride, buffer size, and buffer. Now, in general, how this is working is that you have this PRC. This is a copy rectangle. This is the rectangle from where you want to copy. Then you have a human CB stride. Stride is kind of like the size of one row in the image. Then you have the buffer size, which is like the total size of the image that you want to copy, and you have a pointer where the data shall go to. So we need to do a bit of more math before we can do that. So first of all, what we do need is the stride. How do we compute the stride? Well, actually, it's quite simple, right? It is the BPP, so data bits per pixel divided by 8, so that we are at bytes. And then we need to take that value here, that BPP, and we want to multiply this with the width of the image, right? Because the stride is like one row. This is kind of like how many bytes per pixel it is, and this is how many pixels we have. Now there's one thing that's gonna fall short here if you're using that, and this is if you have an uneven or a not aligned to 8 pixel format. So if data BPP is like, let's say 10, if we would divide it by 8, it would still be 1 byte. This doesn't work because 10 pixels would mean, or 10 bits per pixel would mean that we have 2 bytes that is required. So what we need to do is we need to do a bit of pre-processing. Basically what we do is we add 7 and then we divide it by 8. Now this looks a bit odd, but this is actually working, because if you would stay at the example of like 10 and you would add 7, you're at 17. No, was it 10 did I do? Yeah, 17. It's actually correct, yeah. 17, and now you divide it by 8. 17 by 8 is still going to be 2, which is the actual pixel values that we need. And so what we can do is we can compute the stride with that. So by having the stride, we can compute the size of the buffer. The size of the buffer is basically the stride, so how big is one row, multiplied by the height. And then we have the correct size. Now what we need to do is we need to make sure that data is correctly reserved or resized. And I'm going to resize the vector to the new size that we need. This is required so that we have enough pixels available. So now you can see we already have good information that we need. We have a stride, we have a size, and we have a now quite odd looking function call to the data buffer, which is of course not a byte pointer because it's a char pointer, but we can convert it to a byte pointer like that. So inside of the data member that we have given to it, we go into the struct member called data and call the data function. It looks odd, but it's the correct way to do it. Now what we need is the WIC rect, the rect rec for copying. WIC rect, come on, there we go. Copy rect, and we need to make sure that the WIC rect is initialized correctly. So x equals y equals 0, that's quite simple. Then we just need to specify a width, and we need to specify our height. Of course, they are in data, like that. And this is basically just telling WIC which part of the image to copy, because you can just copy a certain part of an image. You don't need to copy the full image. And if I now make a breakpoint here and press a 5, what you should see is that this gets decoded properly. We have not put it in some checks, so that's not good. But what you can see if I would open up data is that we have something in here that might seem legit. Alright, so the next thing that we should do is we should again, because this is I think a H result, yeah, put in a bit of error checking. And actually down here also the return true somewhere. And this should now be good. Now the only thing that's left to do is finding out the pixel format for DXGI. How can we do that? Well, we need a way to assign DXGI and GUID formats. So we need to have a lookup table for these two. And I'm gonna do this with a vector. So let's do a private static const std vector. but the STD vector needs to have a bit of data in here, so we're gonna have the GUID to DXGI. That's gonna be our struct, which is the GUID WIC and the DXGI GI member in here. Not a DXGI, a DXGI format GI member in here, and then we can store them in here and call them as lookup table. Now we have the lookup table. Let's go into here and let's initialize the lookup table by providing namespace image loader as lookup table, and then we're gonna set this to equal, and then we're just gonna provide a set of initializers. Now, how does these pixel formats can be looked up? Well, the GUID is actually also defined. The GUID for pixel formats are also defined. They are defined in here as GUID underscore WIC pixel format. And you can see, if I take a look at these, you can see I had a lot of pixel formats that are available throughout WIC, but I'm gonna only use a few ones that are relevant for us. We're only gonna use 32-bit formats. We're gonna use 32 bits per pixel BGR. I don't think that this is actually something that we could currently use, so maybe we don't want to use it. We only want to use the ones that work. We want to only use that one, BGRA, and we want to use RGBA, because these are two common formats that you need to support. BGRA because many pixels are not encoded RGB but BGR and then A. And what we need to do is we need to find a certain DXGI format. So DXGI format R or B8, G8, R8, H8, UNORM. That's a certain pixel format that's associated with that. And then we have the same for RGB. So it's just like a swap channel, and this is what we're going to use. BGRA is what we currently had. We're just going to support these two pixel formats. If we need more in the future, we can add the support by basically making the lookup table longer. And there's also a way to convert between pixel formats, but that's something that's a bit too advanced for now. So what you could do is you could look up if the pixel format is supported by that lookup table, and if it's not, you could create a pixel converter that converts the whole image into a different pixel format that's then supported. You can, this is like the beauty of WIC. You can convert around like nowhere. That's so amazing. So I think we would want to have a bit of algorithm now to look this up, because what I want to do is I want to do a std findef. So std findef in my lookup table, begin to end, and then we're gonna have a lambda function in here that's gonna do something. Now that lambda function is gonna get a GUID to DXGI reference, actually a const reference. We're gonna call this one entry. And what we want to do is return memcmp to memory compare. I want to memory compare entry.wic. And I want to compare entry.wic to my data WIC pixel format. So I want to compare these two GUIDs. You can't use the equal operator because it doesn't work. And if this one is 0, it means that they are equal and that we found our member. So let's do a auto find it. The find iterator equals to that. Now, if find it equals as lookup table end, I want to quickly do a return false. And if it's not the case, so everything worked out correctly, I can say format GI pixel format equals find it GI. So the copy over the property here. And now, actually, this one should be finished. We could make maybe a breakpoint now in here, because now I think that my my loading routine should be correct and finished. And let's see what it does, if it does what it should do. And you can see that we have a breakpoint here. I have my texture data in here. And you can see that we have a buffer, the data, width, height correctly, BPP correctly, channel count correctly, and we have a DXGI format of BGRA, UNorm, and 8-bit, which is exactly what our image is. And this means that we now have correctly loaded the image on the CPU side. And now we just need to allocate some memory in the GPU, copy it over to the GPU and alter our shader and do a bit of support for our shader so that we can support drawing textures. So that's it for today. Thank you for watching. See you in the next video. Make sure to like and subscribe and have a nice day. Bye.